Dividing polynomials, section 4.3, focusing on synthetic division. And synthetic division is a shortcut to long division. Also, we're going to talk about the remainder theorem. A couple things to remember first is if you have a polynomial in factored form and set it equal to 0, you know that x is actually equal to 2 and x is equal to -3. Either this equals 0 or that equals 0. And so you would see that x would be those answers. If I had it in the form of x minus k, I'd set that equal to 0, and I would see that x is equal to k. I'm going to apply that later on. Now, when I get into synthetic division, first of all, very important that this has to be in that form. The divisor has to be in the form of x to the first power minus or plus k. And this has to be a 1. So if you have a divisor that's in this form, a coefficient of 1, degree of 1, then you can divide synthetically. The other ones, you would do it by long division. So for example, I'm going to go ahead and say that x minus 2 is equal to 0, so x is equal to 2. 2 is what I want to use in the synthetic division. So you put 2 up here. Notice it's not -2. I set equal to 0 and solve. I put 2 up here, and now I'm going to get the coefficients of that polynomial. 1, -3, -7, and 6. Notice, none of these are missing any terms, so I don't need to put a 0 term in it. I carry down the 1 always, and then multiply. So I'm multiplying 2 times 1, and then I add down. Multiply, add down. Multiply, and add down. Now notice that you get that number. That is the remainder. And so this quotient is equal to, and this is the constant, x term, x squared term. When I say term, I mean the coefficient of the term. So this is 1x squared minus 1x minus 9, and then the remainder is minus 12 over x minus 2. Now, be careful because sometimes there's missing a term. Again, you'd set it up like this with synthetic division, solving for x, -3. 2, my squared term is 0, -1, -7. Bring down the 2, multiply, and add. Multiply, and add. Multiply, and add. So the remainder here is going to be 58. Again, the quotient is 2x squared minus 6x plus 17 with the remainder of -58 divided by the divisor x plus 3. Only time you can do that, again, is when you have a coefficient of 1 of the divisor and a degree of 1. Now, notice that these are the remainders when you do the synthetic division. There's a theorem, that's the remainder theorem, and it says if you have a polynomial divided by x minus k, the remainder is when you substitute k in for x. So what that means is you could do it synthetically, or you could just plug in -4. So notice it's not a factor here, it's x equals -4. So if I put -4 here and evaluated it, this would be equal to the remainder. You could do it this way, or you could also do it by synthetic division, setting it up and finding the remainder at the end. be careful. This says x equals the number. It's not a factor. So I would just find out what is f of 5 or what is f of 2, either by substituting in or by using synthetic division.